Hello, my name is Monika and I'm from University of California, San Diego. This video is an example of how the GNPS dashboard can be used to study a cosmopolitan marine microalga. This video is an example of the supplemental data to the GNPS dashboard collaborative analysis of mass spectrometry data in the web browser manuscript. In this example, we'll discuss Pseudonychia australis, a marine microalga capable of producing a potent neurotoxin domoic acid when undergoing nutrient starvation. In the context of studying Pseudonychia australis's metabolome, I needed to use 3 LCMS platforms: a Bruker Amazon ion trap, an Agilent 6530 QTOF, and a Thermo Fisher Scientific Q-Exactive Q-Orbit trap. As all 3 platforms come with their own vendor-specific data analysis software, the GNPS dashboard facilitated my work in this multi-laboratory and multi-instrument data analysis. So let's go into the example now. In Figure 12 of the supplemental information, we see visualization of mass spectrometry data of aqueous methanol extracts of Pseudonychia australis. In Panel A, we are seeing extracted ion chromatograms on the left and mass spectra on the right, extracted for M/Z equals 312.1441, the mass of domoic acid, from the ion trap on the top, the QTOF in the middle, and the Q-orbit trap on the bottom. Now we will go into the GNPS dashboard to visualize how this data is acquired. For the purposes of this video, I will, going forward, only be showing QTOF and Q-orbit trap comparison, but please note that as many different data sets can be compared at one time, but for simplicity, we'll focus on 2 for now. So now I have moved into the GNPS dashboard. Under GNPS USI file selection, I've put the links for both the QTOF data on the top and the Q-orbit trap data on the bottom, so I have 2 files. Under XIC options, I've entered the M/Z for domoic acid 312.1441. Under XIC tolerance in Daltons, I've selected 0.02. My XIC integration will be by max peak height, and visualize grouping by file. Due to the use of different platforms for data analysis, we expect the absolute value of the intensity of the peaks to differ. To resolve this problem and ensure proper comparison, the XIC normalization toggle feature here is turned on to clearly and easily compare visual data. So now when I scroll down to data exploration, I can see here the XIC plot grouped by file for the QTOF and the Q-orbit trap data. I also can integrate these peaks very easily with this XIC integration feature down here. The next thing I'll point out is the heat map for data exploration. And in order to look at this heat map, I'll be looking at one file at a time. So first we'll look at the QTOF. So here we are seeing a heat map that shows the total ion chromatograms from the QTOF. This heat map is very useful to provide a direct comparison of the global data structure, including the MS-MS events. So here we are seeing M/Z versus retention time as a 2D LCMS map. The blue crosses represent triggering of MS-MS data collection. As we can see in the QTOF data, the blue crosses are dense, and dynamic exclusion is not utilized, causing multiple MS-MS to be triggered along one peak and reducing the metabolome coverage of a molecular network. I'll also point out that I can select any of these MS2 acquisitions and acquire the MS2 spectra, the mass spectra here. Next, I will look at the Q orbit trap data in a similar manner. So here, when we're looking at this heat map, we can see that the blue crosses are much better distributed across the data. And because dynamic exclusion is utilized, we are getting less reduction of the metabolome coverage. Hence, it is not surprising that when we look at our downstream molecular network data as visualized in Figure C, the majority of the contribution of chemical space is coming from the Q orbit trap data in red. In summary, the GNPS dashboard directly benefited the investigation into Pseudonychia australis metabolomics by allowing for rapid and efficient comparison between 3 instruments with different data analysis platforms. The GNPS dashboard will serve as a valuable data integration tool for analysis going forward. In this tutorial video, we have explored how to generate all of these plots for an extracted ion chromatogram, mass spectra, 2D LC-MS heat maps, and molecular network comparisons from 3 different instruments. Thank you.